Hello, everybody. I'd like to welcome you to the fourth webinar in our Soybean Innovation Lab webinar series. Uh, so, for those of you who have joined us before, we have archived the other webinars, and they can be found on our website, and each of them are listed here. Just to remind you how this will go, as the webinar is given today, you can enter your questions under the question panel. There will be several opportunities probably for where I will read the questions and then the presenters will answer them. So I want to give a little introduction on today's webinar. Most of us are on this webinar series because we're trying to solve the problems that seem to exist with mechanization introduction and use in Africa. Although much of the necessary equipment has been invented, it does not easily make its way into many parts of the world. Many reasons for this have been identified, such as lack of a value chain for imported equipment, lack of credit for potential users to purchase equipment, low yields that keep profits and the potential for reinvestment low, and what has historically been a surplus of cheap labor, although now you see a lot in the news that labor patterns are probably changing in Africa and that cheap labor is becoming more rare. But for me, a big problem appears to be the lack of local investment in making a productive market for agricultural technology. I believe that Africa should and can be meeting their own equipment needs, whether that be by large regional fabrication companies or by small local blacksmiths with a strong will. Some problems with local production may include economies of scale, ability to get raw materials, and access to milling or other equipment to make parts. But difficulties in establishing a paying customer base looms large. So what will help farmers take the plunge and invest in equipment? Or is the answer that entrepreneurial service providers rather than farmers are the customer base? How can farm equipment become as ubiquitous as cell phones and motorcycles? First, it has to be as useful as cell phones and motorcycles. Something really different needs to happen to make equipment as desirable as that. Perhaps that difference in Africa could be accomplished by developing a system that allows many different players to have a stake in the game. Do you all remember a time when all our phones did was make phone calls? Once the operating systems were opened up to entrepreneurial computer code writers, every sort of app you could imagine was developed. A lot more people got to be in the game, and phones became a lot more useful. So, can the same be done with agricultural mechanization? Can we all work off the same platform and build a modular system around that? Can participatory development bring new energies and ideas into a stalled system? When I first met Lockie Catrone and Horace Clemens while they were traveling with their Oggun tractor, I realized that their ideas on open systems could be extremely useful in Africa, where enticing people to take risks on equipment investments is needed. I also saw the potential of the Oggun tractor itself in Africa. While the tractor is smaller and has much less complexity than the big mech modern tractors we're used to seeing, discussions with farmers in the U.S. who'd used the old Alice G, which the Oggun is modeled after, reported that the tractor likely has a great deal of capability and usefulness for small to mid-sized farmers, and that's on an American scale, so anywhere from 10 acres to a couple hundred acres. I see this as equipment that can be built and maintained in Africa by local fabricators. Parts can be made there, and service providers who are not expert mechanics can master this machine. The icing on the cake is the Oggun vision of an open source architecture and a common power platform. As we move forward in attempts to mechanize agriculture in Africa, I think we must all allow ourselves to venture out of the belief systems we have become immersed in. Ask yourself, what if I left my little niche where I get all the credit for my work, and I went to work on something in open collaboration with everyone else working on the same problem? What if this group effort could actually come up with solutions that get put to use in the field? So now here to speak to you about a different way of thinking about mechanization development is Horace Clemens and Lockie Catrone from CleBer LLC. Sorry about all my mispronunciations. To give you a little bit idea of Horace's background, he was born in rural Alabama in 1943. He worked for IBM from 1965 to 1983 and is a U.S. Marine Corps veteran from 66 to 68. He started Post Software International, which he ran from 83 to 97. It had offices in 7 countries employing 400 people. It was the first company to use PC as a business transaction computer. He established Open Systems Software Business Model in 1984 and established the first valued customer program in the nation with VA Supermarket. In 2000, he sold the company and moved to Alabama. He's been a Jackson County, Alabama Commissioner from 2008 to 2012. He had a 2014 failed state Senate race. Must be not some very good voters down there. He started native marketing in 2015. Lockie's background, she graduated from Iowa State with a degree in agricultural business. She developed a passion for small-scale agriculture and local food systems while in the heart of Big Ag. She worked on a project in Tanzania while in college, which started her interest in international development. So now Horace and Lockie are going to take over, so give me a second to change presenters. Okay, you guys, we can see your slides now.
Okay, give us 1 second. There we go. All right. Well, hi, everybody. Thank you so much for having us today. I'm Lockie, and this is Horace. And as you can see, we are in the mountains of Alabama right now. So this is where our office is. And yeah, good morning, Horace.
Good morning to everyone. And I hope that we're able to get our message across clearly. I believe we really can have a significant impact.
All right, so we'll just dive right in. So really we want the focus of this presentation to be even more on the questions and discussions that follow it. So as we go through it, please be thinking about any questions that you have, things you want to talk about with us, because that's where this will really be valuable for all of us. All right. Okay, so just to set the stage and go ahead and remove any doubt about what we suggest, whether it's possible or impossible, I want to put this slide up there, just something to think about. So if we can send a person to the moon and back, if Elon Musk can return a rocket booster from outer space and land it on an X, then nothing that we've discussed today is going to be even remotely impossible. And I promise it's every bit as worthwhile. So we know that just one only has to want to make things happen for them to be able to happen. And we want to really hone in on that passion today that I believe everyone at this webinar has. So our goal today is to convince you that we can have a significant impact on global food production while also providing business opportunities for women. And we'll really only be able to do that together. Okay, so speaking of Elon Musk, we want to just throw up some stats here. So looking at the top 20 tech companies of all time, it's interesting that Elon doesn't even make the top 20. I'm sure someday he will make the top 10, but not yet. So these 20 companies, they have some obvious things in common. They're obviously tech companies, and all of them have created significant economic opportunity, made a lot of people very wealthy, not only their founders and the people in the company, but the businesses that have been built because of these companies. But there is something that's not as obvious that all of these companies have in common. So we take a closer look at who the founders are of each one of these companies, and we see that there's not one single woman on this list, the whole top 20 list. If we would have asked you at the beginning, how many women do you think are going to be included in the founders, you probably would have at least said 1 or 2. Some of you would have said more than that. So unfortunately, it's not super surprising, but this is something that's not right. It's something that it shouldn't be that way. And so in looking at this, we know that we have the opportunity and the obligation to do better than this. And so what we're all looking at today is how do we solve the problems that we have in agriculture, and how do we do that in a way that gives opportunities to women and sets that stage from the very beginning. Okay, so how do we go about solving this huge problem? The very first thing is that we want to solve it. We have to want to solve this problem, and I think that already exists with the people that are on this webinar, everyone here. And looking at the other webinars that have occurred, we've seen a theme that female empowerment is a very important part of this whole puzzle. Next, we have to give women the opportunity that they deserve. So, you know, it's so important thinking about female empowerment and how do we tap into the passion that exists within all these women around the world. It's in there, but we just have to empower them and to bring that out and give them the opportunity to pursue the passion that they have. And it's something that's talked about a little bit more with the people that are on the ground doing development work. But the other piece that we want to focus on is how do we make sure that that exists within industry, and how do we make that goal and that message at the forefront of the industry, that, you know, we're about people, we're about women, and we're all about the power of people. So we also need to look at the business model that has enabled all of the men in the tech industry to generate a lot of wealth, but also provide platforms for entrepreneurship for lots of other people. And so when we look at that model, it really starts with the PC, which was first built in 1981. So as you heard in Horace's bio, he was one of the first entrepreneurs in the 80s that was a leader in this open source software movement. So he's going to delve more into that model in a bit. But before that, we want to look at how it all started, starting with a guy named Don Estridge. Now, this is a name that most people probably have not heard of, but he impacted every single one of our lives. So Don, I'll just read his description. An IBM employee since 1959, Estridge headed up the skunk works in Boca Raton, Florida, that in '81 launched the IBM PC. Estridge made the decision, revolutionary for that time and place, that made the machine that would be made from off-the-shelf, easily obtainable parts, and that the design specification would be made public. So what Don did that was the most important, or what he did was the most important technology event in the whole history of computing. I mean, he was the first guy to go and say, to make something that was non-proprietary, and it changed the way that all business was done. And then in 1983, Steve Jobs made Don a multi-million-dollar offer to come to Apple as the CEO. Don turned it down. They ended up getting a Pepsi guy to fill that position. He went and fired Jobs, and then there's a whole story. Horace can probably delve into that story because he was there. So Horace is going to delve more into that model, what it looks like, what he did, and then we're going to talk about how it connects to agriculture and what we're doing today.
So first, I'd like to, start with the issues. Don really changed everything with that movement of saying he's going to publish the design of the PC. So when the PC came out in '81, the only thing on it that was truly IBM was the logo. And so we have evolved from that start of a big bulky PC that weighed 10 pounds or so to a computer on a chip. And his making everything open allowed all the things that we have today. So off that computer on the chip, we have connectivity architecture that's well defined. And that connectivity architecture is layered on top of, that's how all the different types of devices are connected. So all the displays, the keyboards, everything gets connected on top of that. And so really with the architecture that we have in place, once you get to the device, every device has the ability to connect all types of storage. So in your phone today, you can have gigabytes of storage, which is significantly greater than anything we even envisioned in '81 and '83. And now on top of that, we have multiple operating systems. So we have the Apple iOS, we have Android, which is used predominantly in every phone, and it's about 90% of the phone. And then we have Windows. So all these things, these were the complex things. So I've written code at almost every level within this architecture, and it's just very, very difficult. So if every programmer had to program at that level, we would not be where we are today. But on top of that are all the development tools, and the things that I was familiar with early on was, the C+ languages, and a lot of the things that we did were done in the basic assembler language. But today we've got HTML development tools. We've got tools where my grandson, when he was in the 5th grade, wrote a computer game. So the development tools have expanded such that today business applications are exploding. So most of the people that work on these things are using development tools, and they're not even aware of the device that they run on or the devices that are attached to that computer device. So they don't know if their output, their application is running on a screen on a telephone or on a massive screen attached to a bigger computer. So across the gambit of this architecture, everything looks the same. So we could now exponentially explode productivity because of the architecture and platform that has been developed over time. So a lot of what my business partner, Saul Barenthal's son-in-law, who I've known for many, many years, when he saw what we were doing with the Oggun tractor, he said that I was just a one-trick pony, that all I did was the same thing that I did with software. And I said, well, he's right, but I didn't invent the trick. Don Estridge invented the trick.
Okay, so you can see kind of where Horace started and how he developed these concepts, and we're going to overlay another pyramid that is showing the same concept in equipment, and we'll explain kind of how that works, but it'll be easy to see that this is where it started. Okay, so on the equipment side, we start with the very basic, where does your power come from? The engine, gas, diesel, electric. And you look at the power beyond, that's going to be your hydrostatic and your hydraulic. And now the combination and what's selected between those two first levels is what creates the universal power platform. And this is just a modular component built from both of those two that really provides the base structure for a piece of equipment. And that base platform is scalable, so it's not just one size, but that's scaled. And then you can look at the device drive or the power beyond and think of the power beyond as the device drivers. So we keep on moving up to the cross-function subsystems. So it's going to be your wheels and tracks, the required lifting, pulling, pushing, digging components. Then we move on to the implement-specific subsystems. So these subsystems are just built on top of that power platform, and that's when you start to get your actual pieces of equipment from there. So what this pyramid is really trying to show is how we design equipment. And so right now, the traditional way of designing equipment is to first think about what you want to design, whether that's a tractor or an excavator, a combine, and then work your way down. But what we're proposing is working your way up the pyramid and starting at the foundation.
If you look in 1981 when the PC came out, every computer business was a vertical business, not a horizontal business. So if you bought your computer from IBM, you bought your software from IBM, and you had to pay IBM service people. So the thing that Estridge did broke that model completely apart from being a silo, a vertical business to horizontal businesses, so that you can, things that run on your computer, you can select where you buy them. Today, the equipment business is a silo, is a vertical business, just like computers were in 1981. John Deere, if you buy John Deere, you get service from John Deere. You have to pay his high-price people. The parts come from him. So it is, the business model is very similar to what existed with computers in 1981.
And so you can see that what we're wanting to accomplish with this is the same thing that was accomplished in technology, where instead of someone having to, if they want a piece of equipment, build this whole pyramid from the very bottom, that foundation already exists for them to just work at the high level. All right, so we'll look at some examples. So we'll look at equipment example and then an implement example. So that top picture there, that is a universal power platform. And so this is just one example of we call it a UPP for short. And this is what we use to build the Oggun tractor, but you can see that that same platform can be used to build a small truck or skid steer, excavator, other pieces of equipment. We're looking at a combine right now also. So you can think of the UPP as a computer on chip. If you think back to that first software pyramid that we looked at, this is kind of where everything starts. And it provides for scalability of that power beyond. All of the connections are well defined and published. So from here, I just want to go ahead and take the chance to ask everyone, do you believe that this is possible? Also, do you understand what we're talking about? And if anyone's asked any questions up to this point, Carrie, just jump in and we can answer any questions. But if you do, or you can save them till the end. But keep thinking about those questions.
Okay, nobody has any questions yet, but if anybody wants to say anything about the idea of open source mechanization, you can say it at the end, or if anybody wants to pop up now. So we're not having anybody type in, so let's go ahead and move on, Lockie.
Okay. Okay, so next we'll look at the implement example. So when you look at this, this is more showing the migration path that's included in the architecture. So this particular example isn't your typical Power Beyond model, but this is really the reality of where we need to start. Most farmers in the world are working at the manual and livestock labor as opposed to the actual power labor. So we have to meet people where they're at and start where they are. And so that is at the manual side. So in anything that we build, we always must provide a migration path from that human and animal power into the powered architecture. So this is where the hand tool companies, Johnny's and Haas, that's really where they come into play. So looking at those photos, you can see that we start with that the push seeder, and then we want to carry as many components as possible from the push seeder to the next stage up, which may be a walk-behind tractor or a small four-wheeled tractor, and then move as many of those components up again into a multi-row platform. So it's all about bringing along as many components as you can, protecting the investment, and giving people the opportunity to move up.
We also protect the knowledge, and so once a farmer learns to use a specific implement, by migrating that up the stream, the farmer really doesn't have to learn anything new.
Okay, so what is the proper combination of equipment, implement architecture, and business model that is needed? It's very obvious to us anyway that both are needed. Those two things can't be separated. I think we just talked about the architecture side, and now we'll delve more into the business model side that goes right along with the architecture. So we want to take everything that we've learned from the tech industry, from software, and go beyond what they've done and do better than what they've done. So here's our business model that goes beyond. So we'll make another analogy here. You can see there the ARM model. So ARM is a company that was started, what, in the 80s?
Yeah. Well, in the late 70s.
So they were a company that first, they tried to make a PC at that time, like many of the other companies that were out there. They weren't very good at making a PC, it just wasn't their thing. But they realized that they were really good at making chip architectures. And so they ended up making a chip that was very small and high-powered, and they just started doing the design work for that chip. So today, the ARM chip is actually in 95% of the cell phones in the entire world. Yet ARM doesn't manufacture anything. So they just do all of the design work, and they license the design and the architecture out to all of the cell phone and different businesses out there that use that. Say any more on that?
It's a model that's proven very successful for them. So ARM, Advanced Risk Machines, what the acronym stands for, it is a very, very successful British company. And Lockie will go more in depth of how we believe that model is applicable to universities throughout the globe to participate in the design that she talked about earlier and get royalties for licensing.
What we're proposing is the same thing as the ARM model, but even beyond just doing that through a business. We believe that there's an opportunity using this model. By the way, this is the model that we use with the Oggun tractor globally. We believe there's an opportunity for universities, even individuals, to license architectural designs and equipment for small fees to anyone in the world. And that means having the designs published and available for people. This will really allow for local and regional manufacturing with locally sourced parts, which is also what we're doing with the tractor. And it creates a low overhead and cost of entry model. because that means that if you're just working with intellectual property, licensing those designs, you can go to any machine shop in the world that already has the equipment and already has put in the investment and probably has some excess capacity that they need to use, and they can build, either the component, subcomponent, or the piece of machinery that has been designed. You have more to add to that?
I think the way we deal internationally with companies is that we give them the design and encourage them, in essence, to put us out of business. So our goal is, here's how the tractor's built, build the pieces that you can, and that within 5 years we expect you to be building the entire tractor. So our licensing model is we sell them as much the components that they cannot build initially, help them get to where at a point in time they can build. We have one country we're dealing with that we believe they will be able to completely build the tractor within a year, and our licensing model says we just get a small fee per tractor, and they really make the money. So everything that we do is to encourage the money to be kept in the country and used in further development of further equipment.
Okay, so how does this model and this approach create opportunities for women? That's what this whole focus is on. We're not looking at how do we solve the problem, and I'm talking about individual problems, specific problems, but we create the ability for individuals to solve the problem that exists in their space. So we can't ever predict what the next problem is going to be. It's always going to be continually evolving. So going in and trying to look at just one thing specifically is just not a sustainable model. So we want to back up and look at the bigger picture, all work together on the bigger picture, so that then we provide that basically a platform for anyone to go and solve those specific problems that exist.
In looking at how we make this happen, we realize that in a lot of the countries, the tractor will only be something that a very small percentage of the farmers can use. So we've had conversations with the people at Haas Tools and other places about taking their designs and make them public, similar to what we've done with the Oggun tractor. At first, there's a good bit of, well, why would I do that? Somebody's just going to copy it. And I said, well, but what if you looked at the market and you said all of a sudden the market potential for licensing the design and helping people manufacture what you manufacture goes into the millions and millions of people, and you will never sell to that many people. So if you open your mind, you understand that you can make as much money, similar to what ARM does, by licensing the technology all on a global basis rather than just selling it to the organic market here in the United States. So we're still working and struggling to try to make some of these executives that are in the equipment industry be willing to take that risk, but I believe we will get there eventually. And the more support we get in this effort of making people aware of what the total market is will help.
Mm-hmm. And so really what we're saying is unleashing a new environment of open systems that gives us the chance to create female leadership in a new space where the space doesn't exist, we're creating it, and so why don't we start from the very beginning giving women the opportunity that they deserve. So what's the next steps? What's the purpose of this? What do we want you to do? So first is participation in the establishment of an architecture control group. So when we go back and look at what we were talking about before with licensing designs, and you look at what is done in the software industry, it's very important to have a group that manages all of those designs and manages that licensing process. And so what Horace learned from creating different standards bodies and control groups in the past was that it's important to not have just the business community involved in that. When you have only businesses, it slows down the process because everyone is fighting for their little piece of it. And so what we're proposing is for an international organization to kind of lead up this effort and be the leaders of the control group to manage that. And then businesses and universities will contribute with their designs to that organization. The second thing is money to fund Soybean Innovation Lab's Combine Competition Project. So this is a project that we've just started to work on with Carrie Clark in the Soybean Innovation Lab. And the goal here is to really prove that this model works and also provide opportunities to students that want to get into this world. The goal is to use our universal power platform that we built the tractor with and give that to groups of students. We want students to create teams, so have engineers, business students, agricultural students, to take that platform and work on building a combine that will work for Ghana specifically, and then to go through that whole process of looking at doing the design work and then looking at how do we actually implement this, how do we manufacture it, how do we sell it, how do we distribute it, and so everything from design to actually delivering it to the customer and ensuring that it works in the field. So we want to make this into a competition where multiple teams of students can contribute, and in the end there's a winner, and part of that is a cash prize and the chance to go to Ghana and actually implement this project. Did I miss anything on that?
I think you got it.
All right. And the third is identification and sponsorship of establishing an open systems equipment implement manufacturing facility in an African country. So I think that one's pretty self-explanatory. So that is all we have on our presentation. So now we would like to just open it up to discussion and questions. And
Lucky, can you go back to the slide? Was the upside down pyramid for the equipment?
Sure.
Okay, can you talk a little bit more about how people would come into this, how they would work with you, and how they would make money?
You want to take that one?
Well, we've published the tractor design, and the chart that we showed shows that design, because it's has a hydraulic drive system, you can make almost anything out of it. So we've made a tractor, and we know somebody could take that design and turn it into a truck. And so we have the project we're trying to do with you to turn that into a combine. So people could take that, we'll publish that design, people could take that design and make any type of equipment. So a lot of this, we've seen small farm equipment disappear. And so the easy thing to do is look at some of the old equipment out there and reverse engineer to layer on top of the powered platform. The thing that we will require in this is that anybody that develops a piece of equipment do like they do in the software world. That if you take the design and add to it, you publish your design also as an open systems design, but you can also collect the royalty. So any design that people create. So we're working with a university here in Alabama, and they're helping us with some design issues. I think one point that we didn't mention, so we have sold tractors in 18 states to how many land-grant universities?
About 6 universities.
6 land-grant universities, and in 6 countries. And you're looking at the total employees of our company. So the business model that we have is significantly different. So we publish the stuff, and anybody can look at it and say, well, I want to build a big sprayer system. And I said, well, that one's really, really easy. I mean, just take the parts that we have and make a sprayer, a sprayer system. So we haven't yet started on a light truck, so somebody could easily take what we've done and do the design for the truck. Then they could either manufacture it themselves and make money that way, or they could license it to somebody for them to manufacture. Did I get it, Carrie?
Yes. So
one more point. So universities. So if we look at the universities between their engineering schools and their ag schools could easily take this design and design a myriad of equipment, and then build a prototype to show that it works, and then license that design all over the globe and generate license revenue.
okay, and on the power platform, how's that been tested, and how much power does it have?
Well, the power is scalable because the architecture just says I have an engine that is set with an adapter that will drive stacked hydraulic pumps. So it's part of the architecture. It's kind of scalable on the same way a PC is scalable. You have chip processors that range in power from what's used in a phone to what's used in a supercomputer, and so that power platform is scalable by increasing the horsepower of the engine, be it electric, diesel, or gas, and increasing the output power of the hydrostatic and hydraulic pumps.
So the Oggun tractor as it is right now, how many horsepower is it?
We use a 22 horsepower engine in the Oggun tractor. So for the uses of a tractor that small, that has proven to be significantly beneficial because we don't have to use a big engine. 22 horsepower, a lot of people wonder if we can do very much with it, but we've shown them that we can use a chisel plow and easily chisel plow most soil that we've run across. But if we have to upgrade it to a larger engine, so that the engine mount base is designed so that we can upgrade horsepower on the engine without changing the rest of the design of the tractor.
So how would you see this working, people coming together and working on an open source, like kind of, I guess maybe go back to the tech comparison. How did people start to realize that they could make money adding to the PC, or working with the licensing there? And how do you see that transferring to equipment? How do we get the word out? How do people know? How do people get to test the power platform? How do we need to have conferences? What do we need to do, you think?
Well, I think the advantage the PC had was Don Estridge violated all of IBM's business rules, and there's some stories behind how he really managed to do that by producing a machine where in his mind he was producing a machine with all off-the-shelf parts. So having the IBM logo on that, when that hit, the world caught on because they said, oh, here's something with the IBM logo on it. And Dell and Compaq and all those guys, I mean, everybody put IBM out of business. IBM's business is totally different today from what it was. So we have to have the conferences. I mean, I believe that for us to get the momentum we need some of the foundations involved, we need the universities involved, and we need to have a conference that brings in those groups of people to try to get the message to them. We need to get to the Gates Foundation, the Buffett's Foundation. We need to get to the Push organization, and we need to try to get everybody to understand that the same thing can happen in agriculture that happened in technology. And like I mentioned, we have to learn from the lessons and do one better. The one better that we can do in this is that we can have an impact in how many women get an opportunity to be entrepreneurs.
So what do you say to, let's say you go to a country where women are not currently entrepreneurs. How do you think we can find them, or how do we convince them, or how do they have the esteem needed to start a business?
I think that's where the collaboration piece comes into play so much. I mean, Horace and I are not going to be the ones, working in every single country, working on the ground, doing everything. That's where we have to work with the people that are already on the ground and are working with those people day in and day out. And they're going to have better expertise than we do about even how to do that.
But the other piece, so I have another business that was mentioned there that I've been working on for over how many years? Over 2 years now. And much like the software business that I started, I said, what I'm going to worry about is the soundness of the business and the first customers that I get, because when we were the first to use a PC as a business transaction processing machine, And I knew that if I had one successful event with a major customer, that I would have more business knocking on my door than I could possibly have happen. The significance of what we're trying to accomplish here, I believe that if we have one significant success, the momentum will carry itself.
I think the other piece of that, Carrie, is, you know, as we're working in individual countries, ensuring that the people that are leading that up are women. Because I'm sure any women that are on this webinar right now can think back to another woman in their life at some point that said, you can do this. You have the ability to do this. And so there's a lot of power in that, just the female-to-female empowerment. And so if we start out with leaders that are female, even the fact that they are leaders will draw in more women.
One thing that might get us a little bit of attention is, you know, when I started my business, people asked me, wasn't I afraid of IBM? And I just shrugged my shoulders and said, no, I'm going to put them out of business. And so I believe that we will put John Deere out of business in the business segment that we're going into.
So when you think about looking for women to do these kind of businesses, it's not necessarily women that would need to be mechanically knowledgeable, but maybe more business oriented?
It could be. But the other piece to look at is if we go back to this slide on implements, most of the farmers in the world that are female, what are they using? They're using hand tools, and that's going to be their comfort level too. So we have to start also where people are comfortable, and so I think that's really initially where a lot of the opportunities for women exist, is in the hand tool segment, and that could be on the design side or on the business side, and I think that they have the capability in both of those areas.
So we are convinced that you can design hand tools where they attach to the handle that you hold in your hand, so that those can be detached and multiple of them paired together on an attachment interface to go onto a walk-behind tractor, and portions of those can even migrate upward to a small tractor. But again, the thing that Lockie and I have talked about a lot is we cannot force progress in any place we go. So that's why we say we have to start architecturally from the human and animal powered device. A plow that goes behind an oxen can be designed such that it can easily be attached to a walk-behind tractor or a tractor like our Oggun tractor. So it is important to understand that the business opportunity needs to be, we are not there to sell something, we're there to help them make something.
Okay, we're going to move to a couple more specific questions about the tractor itself. So one question is, how will this compete with the, you know, right now in Africa you see a lot of the small Massies that are like 65 to 80 horse. So what's your thinking on how will this Oggun tractor compete with that kind of tractor for customers or the ability to get the work done?
Well, the first most obvious piece is the off-the-shelf parts. So if you're looking at Massey or really any other equipment company, multinational company, they're using proprietary parts. The parts are extremely difficult to find. You always end up seeing rusted tractors in the field for that reason. And so we were very intentional in building this tractor and in who we sourced our parts from. So every component on the tractor has at least 2 suppliers, and they're all suppliers that are available on a global level. And so that alone is very significant in people being able to maintain and repair the tractor over time.
But a lot of what we've done mimics the evolution we were thinking from manual and livestock to mechanization. So if you go back and look at some of the early large-scale farms in our prairie before the Dust Bowl, but the technology was such that you could only build about a 20 horse or 30 horsepower tractor time. So those large farms weren't done by one tractor. They were done by multiple tractors, small tractors around the size of what we've done side by side. So our tractor, I believe you could handle any farm 80 acres and below. But again, the price point and the ability to know that you can source, you can build, and you can fix, I would see some of that same evolutionary process where farms would first go from one tractor to 2 to 3 to 4 because of the price point. So, as you get to the scalability, that tractor is going to cost more. And so it's from what we've done, it's all about lay this architecture out there, build the tractor, and let the customers make the decision of what they want to do. They don't have to come back to us necessarily. So once the design is published, they can get their solution from anywhere, just like in the PC software arena. How many different applications do you have? How many different companies do you have producing the same application?
And some other specific points are that the tractor is designed to be extremely adaptable and very open, all the parts accessible. So, I mean, we know that people will immediately use the power of this tractor to power other tools that they have. So they will be able to use that engine power for other purposes also. The other piece that I think is important, especially when we're talking about female farmers, is the ease of use of this tractor. I know in Africa, anytime you're introducing mechanization, there's going to be a learning curve. But with this power being all hydrostatic, there's no clutch, there's no brake lines. I mean, it truly is as easy as it could possibly be to drive. Actually, what we've seen here in the States is that people that have been farming for 50 years, were driving a tractor before they walked. Those people have a harder time learning how to drive the tractor than somebody that never has driven a tractor before. So that's another piece that I think is important in the introduction of power equipment to a place where it hasn't been.
I'll add a comment to that question myself. When I first saw this tractor, of course, I'm familiar with the old Alice G, which is a very desirable tractor amongst a segment of the agriculture community here in the United States, this tractor is very similar to the Alice G, but to me, I look at this tractor and I immediately thought this can be made in Africa, where I don't look at a Mass 65 horsepower Massey and think this could be made in Africa. I have blacksmiths that I work with now that can make your tractor. It's just a matter of how do we get them started in business. I think also that it's not an intimidating tractor. There aren't all sorts of gadgets, gizmos hidden away. You don't have to take off. You don't have to spend an hour taking off shields and covers to get to access the mechanical parts. So, for me, having been in agriculture all my life, to me, I can see that while this tractor may not have as much power or frills as a bigger tractor, I think it's also got some characteristics that would make it very desirable in a country where parts are hard to find and mechanization levels are low. So we do also have another question then about price. And so I know that you have a price point in the United States that's based on U.S. labor costs. What do you think the price point would be in Africa?
Well, a lot of the price point is labor costs. So the model that we propose to everybody is we show them exactly what we pay. And then we say the more parts they can source locally, then that reduces. So everything that they build reduces our margin and increases theirs. So with American, and all of the complex components are from global suppliers. So we deal with Honda and Kohler for the engines. We deal with Eaton and Danfoss for the hydraulics. And both of those companies are global suppliers. So it would be looking at what those components cost and what the steel costs are in the country, and then what the fabrication costs. So it's a hard question to ask what's it going to cost. Based on labor cost and material cost here in the States, as we increase volume, we believe we will be able to get back to something lower than our current $12,500 price, and hopefully back to our initial $10,000 price.
I think that question comes up, how do you achieve economies of scale when you have different people manufacturing the tractor. Now, that's a good thing of people working as basically our distributor, is that they'll be able to get the same pricing that we get from all of these global suppliers of components. So eventually, it might be shipped from the States to Ghana initially, but then we might start working to, get them shipped from somewhere closer, and that'll all be worked out. But we achieve the economies of scale by adding in more countries and more manufacturers that are using these same components. The price will go down for everybody.
It might be worthwhile to mention, so because this tractor was originally built for Cuba, and we made the trip to Cuba and were mentioned by the president when he made his visit, when we came back, we were able to get to executives in Honda and Eaton and Danfoss and Kohler and all those people. And what we said to them is, we want to buy from you and we want to buy 10 units, but we want you to give us as good a price as you give the guy that buys 20,000 units. And they said, why should we do that? And I said, well, we're going to create a business model where we create a virtual corporation where you are part of that corporation, and that will allow us to get a tractor at a price point into a market that nobody can currently sell a tractor into. So that's the model, the business model we followed. So again, I mentioned earlier, there are two of us in this business, but yet we have virtual partners, the fabricator, all of our suppliers are partners. They all realize the potential of what we can achieve if we change the business model from the way things are done today, from the vertical, if we go to a horizontal business model.
So one of the things that as the Soybean Innovation Lab works with you guys that we're interested in doing is getting some tractors to Africa and getting people interested, getting them field tested, but also getting them around to the universities, getting the idea out to students that this is something that they can also work on, that they can start building components and adding to the system. So I don't know if there's anybody out there in the webinar that might also have the same interest. If there is, please contact us, because we know you guys have one going to Ethiopia, and we'll try to follow up on that. But we need to get them out into the field and see what they can do. So there's Horace and Lockie's contact information. You guys can contact them directly. You can also contact us through the Soybean Innovation Lab. So I don't have any more questions or comments coming in. I'll give Lockie and Horace a chance to say one more thing before we say anything else, or before we wrap it up.
I just want to say thank you for everyone that joined today, and as Carrie said, please, if you have any interest in this, you have more questions about it that come up later on, please reach out to us anytime, any one of us.
I've always said that if you believe something's inevitable, just don't get in the way. And I believe that it's inevitable. If we're going to solve the global food problem, we're going to have to do it by enabling the small farmer. And I believe the only way we're ever going to enable the small farmer is off of an open systems platform, similar to what was done with software. So I solicit help from each and every one of you to try to get this word out, to try to help us get to a larger forum so that we can make, faster progress. And I appreciate your time.
And I think that the comparisons to the tech industry, especially, can really help bring some young people in that are interested in becoming business entrepreneurs, service providers, and becoming part of this process. So, some of us are old fogies and don't really think the same way as the young kids. But I think we all need to get together and kind of go in the same direction now. So I really appreciate you guys giving this webinar, and I hope to talk to everybody again soon. So thank you all for joining, and please, if you have any other additional comments or questions, send them to either Horace, Lockie, or I. Thank you all very much.
Thank you.